Another important concept is the polarization. Half cell potential is altered when there is current flow in the electrode because all of those half cell potential values uh, are calculated or measured when the current flow is zero. Overpotential is the difference between the observed half cell potential with current flow at the equilibrium, zero current half cell potential. And three mechanisms contributed to generate this overpotential. The first one is ohmic overpotential. Voltage drop along the path of the current. We have a system, electrolyte and electrode inside it. This connection between these two pieces of our system acts like a resistance. If we don't have any current flow, the voltage which drop on this resistance will be zero. But if the current flow is non-zero, therefore the voltage, the drop voltage will be non-zero too. Therefore, voltage drop along the path of the current, and current change resistance of electrolyte, and thus a voltage drop does not flow off low. We have the variable resistance and also variable current. Therefore, we have a variable voltage, and this ohmic overpotential does not follow Ohm's law. The second mechanism is the concentration overpotential. We talk about the concentration of the ions stored at the two sides of the electrolyte interface. If this concentration or these concentrations at the both sides change, the half cell potential will be changed also. If we want to flow a current, we need those stored charges. Therefore, creating or flowing the current will change the concentration of the charges, ions. We need ions and charges to carry the current. We call these ions, we call electrons and ions energy carrier in the system. Therefore, flowing the current needs to use these stored ions, charges, electrons. But we focus on only ions because we have plenty of electrons inside our metal, and only the concentration of ions at the electrolyte is important for us. And flowing the current will change the uh, concentration of ions inside electrolyte. Therefore, the Hafsel potential related to the stored charge will be changed also. The third mechanism is activation potential. As you can read, current changes the rate of oxidation and reduction, since the activation energy varies for oxidation and reduction are different. The net activation energy depends on the direction of current, and this difference appears as voltage. And the summation of these three voltages, activation potential, the concentration potential, and the ohmic potential will be the overall over potential's voltage. Polarization and impedance of the electrode are two the most important electrode properties to consider. And we will consider these properties at the next slides. In this slide, we want to calculate the Hafsel potential based on the concentration of the ions. And for this purpose, we have an equation, Nernst equation. When two ion solutions of different concentration are separated by semi-permeable membrane, an electric potential exists across the membrane as this equation. A1 and A2 are the activity of the ions on each side of the membrane. Ionic activity is the availability of an ionic species in solution to enter into reaction. Note that ionic activity most of the time equal the concentration of the ion. And also in this equation, N is the capacity of the metal, F is Faraday coefficient, R is the universal gas constant, and T is the temperature in Kelvin. Remember that, in Kelvin. And also Faraday constant is in some text. Faraday constant is this. or okay. For the general oxidation reduction reaction, we have this equation, and the nearness equation for offset potential is this equation.